Now, solution of simultaneous equations using matrices. Now, how do we solve this? We're given a simultaneous equation here, where we have 3x plus y is equal to 7 and 5x plus 2y is equal to 12. So the first thing we do, we extract the coefficient of the variables. The variables are x and y, so the coefficient of y here is 1, the coefficient of x there is 5, the coefficient of y there is 2. So this one gives us what we call the coefficient matrix. Then the variables, now we form a column matrix with the variables so that we have x, y in column form. And then the 7 and 12 now forms what we call the solution matrix. This one is the unknown matrix. It is the matrix that contains the unknown variables which you want to get their values. Now, having extracted the coefficients from these unknowns, from those linear equations, then we find the inverse of the coefficient matrix. The inverse of the coefficient matrix, first we determine the determinant, and determinant is the product of elements in the leading, this is the leading diagonal. Product of elements in the leading diagonal, that is 6, 2 times 3 is 6, minus, we take away, product of elements in the other diagonals, which is 5 and 1, and that is 5, and that one gives us 1. So having got the determinant, then we now get the inverse. Then we say that inverse is 1 over determinant, we multiply by the elements in the leading diagonal altered, where there is 2 we write 3, and where there was 3 we write 2. Where was 3 we write 2, where there was 2 we write 3. Then the other elements we negate. So we negate the other elements. And since determinant is 1, then the inverse of this matrix will be 2, negative 1, negative 5, 3. So that is the inverse of that matrix. After getting the matrix, then you pre-multiply each matrix by the inverse. So it means that the inverse comes ahead of the matrix, and therefore we have 2, negative 1, negative 5, 3. Then we have our matrix, which is 3, 1, 5, 2. We have x, y, the unknown matrix, should be equal to, we pre-multiply both sides. So that is 2, negative 1, negative 5, 3. And our solution matrix was 7, 12. So we multiply this matrix by this. But in our previous discussion, when you multiply a matrix by its inverse, then what do you get? You get the identity matrix. So this matrix multiplied by this will give us 1, 0, 0, 1, which is the identity matrix. Then we have x, y. So the only work that we are left with now here is to multiply these matrices so that we have row, column, that is 2 times 7, which is 14, plus negative 1 times 12, which is negative 12, and then we multiply 15 by 7, which is negative 35, plus 3 times 12, which is 36. So, identity matrix times a matrix, we realize, gives us that matrix. So when you multiply this identity by this matrix, we will get xy And this is now 14 minus 12, which is 2, and this is 35 minus 35 plus 36, which is 1. And therefore, we say that if two matrices are equal, then elements in the same element position are equal. And therefore, x is equal to 2 and y is equal to 1. So that is how we solve simultaneous equations using matrix method.